So every object on Earth is acted on by forces, and these forces dictate its motion. So we have an airplane. Bad drawing of an airplane. We can say that there are four forces acting on it. First, the weight, which is the gravitational pull on the mass of the airplane. Lift, which is the force generated by these wings and the air pushing up on them. Drag, which is a friction moving through the fluid of air, as well as thrust, the force generated by the engines of the airplane. We can actually simplify this into a free body diagram. So if I represent this airplane with a single dot, we could say that this dot is acted on by weight, lift, drag, and thrust.
So now we're going to break down the different components, starting with the force of lift. Now lift is represented by L is equal to 1/2 d, and d is the density of air. It's dependent on the altitude. V squared, where v is the velocity of the aircraft. S, which is the wing area of the aircraft, and CL. CL is a coefficient constant. It is dependent on the airflow, which is how the air travels over the aircraft, and the angle of attack, which is like the angle of the plane. So the next force we're going to talk about is weight. Weight's a pretty easy one. Weight is equal to m, which is the mass, times g, which is the acceleration of gravity, 9.8 meters per second squared. For the airplane to stay in the air, the lift has to equal the weight. Now, if you want the plane to go up, the lift must be greater than the weight. And if the plane's going to fall, the weight will be greater than the lift. So the next force we're going to talk about is thrust. Now, thrust is what moves an aircraft forward. But in order to do that, there's a propulsion system that accelerates the gas in the engine backward, causing the plane to move forward. Now, thrust can be found using the equation T equals m dot E minus m plus E O A. So let's break this down. So m dot is equal to the mass flow rate. So the mass flow rate is the mass of the gas over a certain time. So in this equation, m dot E is the mass flow rate of the gas as it exits the engine, times the velocity, which is the speed of the gas as it exits the engine, minus the m dot O, which is the original mass flow rate, times velocity O, so the original speed of the gas. So then if there's different pressures, you can take the pressure of the gas as it exits minus the original pressure, and then you multiply that whole thing by the area of the engine. So the final force we're going to talk about is drag. Drag is equal to 1/2 CD. CD is the coefficient of drag and is also a constant. It is dependent on several forces of drag, so foreign drag, skin friction drag, wave drag, and induced drag. Then there's P, which is the density of the air, V squared, which is the velocity of the aircraft squared, and A, which is the area of the aircraft in contact with the air.